Let's express each of these vectors in the different ways of writing vectors. Let's start from example 1. In the first example here, my vector is AB. The vector is AB. Vector AB is 2i plus 3j. This is written in coordinate form. I could easily change it to row form by just writing 2 and 3 in brackets, and what I get my answer. I've written it in row form here. So this is now coordinate form, row form. Now let's go on. So secondly, I want to write it in what? In column form. From 2i plus 3j, I can also write vector AB as 2 and 3 underneath it. When I write it in a column like this, with 2 up and 3 down, I've written it in column form. Now, the next form of expressing the vector is in what? Polar form. To write a vector in polar form, I need to express two things. I need to provide two information in broad brackets like this: the magnitude of the vector and its direction. It's easy to find the magnitude of a vector. Given a vector xi plus yj, the magnitude of the vector, given a vector AB, which is equal to xi plus yj, the magnitude of AB is equal to the square root of what? X squared plus y squared. So, for example, the magnitude of vector AB is going to be square root of 2 squared plus 3 squared. That gives me what? 13. So I have the magnitude of vector AB. Now, take note that the magnitude of a vector is different from the vector itself. The vector itself will be carrying coordinates of the horizontal axis and the vertical axis, but the magnitude of the vector is a constant. It can be 5, it can be 10, it can be 9, it can be square root of 70, and so on. The magnitude of a vector is a constant. It doesn't have I and j. So I have the magnitude of AB. I'll keep it. Now let me express AB in a diagram. A is the starting point of vector AB. So let's take A as the origin here, because my starting point for the vector is A. So if you read on the horizontal axis, this is 1 unit, this is 2, this is 3, this is 4 to the right. That's the y-axis or the x-axis, like we do in geometry. This is the negative side. Also on the j-axis, 1, 2, 3, 4, 5 upwards, and -1, -2, -3 downwards here on j. Now vector AB is 2 units on the horizontal axis, or has 2 units on the horizontal axis, and what? 3 units on the vertical axis. So I can express the vector like this: 2 units here, 3 units here. So the vector itself will be represented by a line which starts where my horizontal starts and ends where my vertical ends. So this is the line representing AB. Can you see this yellow line representing AB? This will be vector AB. So take note of that. Now to find the direction of AB, AB is making angle theta with the horizontal here. Tan theta is opposite over adjacent. The adjacent is this side, which is 2 units. The opposite is this side, which is 3 units. So tan theta is 3 over 2, opposite over adjacent. That gives me tan theta as 1.5, and that gives me tan theta as what? That gives me tan theta as 1.5. So theta will be equal to arc tan 1.5, which is 56.3 degrees. Now, when I know theta, all I need to do to get my direction is to subtract theta from 90. The direction of AB is 90 minus theta. 90 minus theta is 90 minus 56.3. When you get used to it, you see that this is pretty simple. Writing vectors in polar form is slightly different. 90 minus 56.3, what does that give you? 90 minus 56.3 gives you 33.7 degrees. So the direction of the vector is, I can write it as north 33.7 degrees east, because this is the north axis, this is the east axis, this is the west, this is the south. So I can write it as, a direction from north towards east, if I like. That's if I'm using acute angle bearing or direction. I can also write it as direction is equal to 033.7 degrees. That's if I'm writing in 3-digit form. So they all mean the same thing. When I'm writing in 3-digit form, this represents 0 degrees, this represents 090, this represents 180 degrees, this represents 270 degrees, and come back here, this represents 360 degrees. This axis represents 360 degrees. So it's the same thing whether you write in 3-digit form or you write in acute angle form. The direction means the same thing. So to express vector AB in polar form now, AB will be equal to magnitude and what? Direction. AB will be root 13, north 33.7 degrees east. If you like to write your direction in acute angle form, but I prefer the 3-digit form. So my vector will be written like this. AB will be written like this. This is in what? This is in polar form. So you notice something here. AB in the 4 different ways is Roman number 1, or let's call it A. 2I plus 3J. That's in what? Column form. Sorry, that's in coordinate form. 2, 3, that's in what? Row form. Third one is in column form. 2, 3, that's in column form. Then the last is in the what? The last one is in the polar form, which is AB is equal to root 13, not 33.7 degrees east. This is how to express a vector in different ways. We'll do 1 or 2 more examples and you do the rest yourself.